let's do a little quick review of supply and demand relationships. So the typical idea with a supply curve is that the quantity supplied will increase if the price goes up. There'll be more of an incentive to sell more of the good if the price has gone up for the firm. So this relationship has that for every 1 unit increase in the price, the quantity supplied will go up by 4. Quantity demanded is a negative relationship with price. The more the price goes up, the less consumers want to buy. So in many instances, we might want to look at the supply and demand curves directly. We're going to have an example in just a minute where we'll look at elasticities. This is a convenient way to evaluate that. It's also a convenient way to look at market equilibrium. But there are also instances where we would want to look at the inverse supply and inverse demand functions. We're simply rewriting the equations 1 and 2 over here, where instead of having the quantity supplied on the left-hand side, we're going to have the price. And the same way with the demand curve, we're going to isolate price so that we can draw a supply and demand curve in kind of a traditional way where the price is on the vertical axis and the quantity is on the horizontal axis, and where this is going to give you the slope. So the coefficient on the quantity supplied, this would be the intercept, and the same way with the demand curve. So these are ways to draw the standard supply and demand curve. So sometimes we use 1, sometimes we use 1 and 2, sometimes we use 3 and 4. It really just depends on the context. But they'll give you exactly the same result because they're just rewriting the same thing in a different way. Now, let's use these equations to look at, say, the equilibrium price and quantity in a market that's defined by these two relationships. Now, one of the things about this equilibrium is that we're going to have quantity supplied equal to quantity demand, supply equal to demand. So we have a relationship for the quantity supplied. We've got a relationship for the quantity demanded. Let's set them equal to each other and then solve for the equilibrium price. Now, if you fool around with the algebra here, well, let me do this simply the first time. So we have 6 times P is equal to 36. In other words, the equilibrium price is $6, if you will. Now we want to look at the amount that's supplied and the amount that's demanded to make sure that we've got supply equal to demand. So let's first look at the supply, and this is at a price equal to 6. So quantity supplied is going to be 6 plus 4 times P. 6 plus 4 times 6, that's 24 plus 6, 30. And now let's take a look at the demand at a price equal to 6. We've got 42 minus 2 times 6, which is equal to 30. So the equilibrium quantity is 30. And the equilibrium price is 6. At that price, supply equal to demand. Now, when we bring in an international trade context, what we're going to see is that we'll need to take into account that the price may be determined someplace else on the world market, and we'll have to adjust some of this, but it's still going to be basically the same sort of ideas. Now, we'll also often be looking at elasticities. And the value of an elasticity is going to vary with the price and the quantity where it's evaluated, typically. Now, you could have constant price elasticity examples, but with a linear supply and demand curve, typically the elasticity will change depending on the price and the quantity. In any event, we have this relationship here. The quantity demanded, the quantity supplied, the equilibrium price, the equilibrium quantity. And now we can look at the elasticity of demand, where that is going to be equal to the percentage change in the quantity demanded for a given change in the prices. It's really how much does demand change in proportional terms when the price goes up by some arbitrary percentage. So that can also be written as the following. It's the change in quantity demanded divided by the change in price. It's the slope of the demand curve, which we can see up here is minus 2 times the price, which is 6, and the quantity is 30. And so what you would find is that if you simplified that, what you're going to get is that the elasticity of demand is equal to minus 2/5 in this example. If we did exactly the same thing, plugging in the slope of the supply curve, okay, so it's going to be 4 times 6 over 30, or 4/5 is the elasticity of supply at that price and quantity. So there'll be instances where we'll need to calculate the elasticities or use the elasticities to see how things might change. And just to give you a little bit of a taste of where we might use this, let's say that you had a tariff on imported goods. That we will see will raise the domestic price of the good. That will change the quantity supplied and change the quantity demanded. How much that supply changes, how much that the supply changes and how much the demand changes is going to depend on the elasticities. And we will see as well that the economic consequences of the tariff will depend on the elasticities. How sensitive are consumers and producers to changes in the price? So we'll use those elasticities in trying to analyze the overall economic impact of a tariff. So just to review this a bit, we have supply and demand relationships, which can be done either directly on the supply and demand functions or the inverse supply and demand functions, rewriting things in a different way, but the same relationships. We can use those relationships to determine the equilibrium price and quantity. We can use those relationships to evaluate the elasticity of supply and demand at the equilibrium or at another price and quantity. So this is I hope, a useful review for you. We'll be using these when we start to look at particular examples where we'll calculate some numbers and not just look at graphs, but to evaluate particular quantities supplied and demand under different circumstances.